Okay, I had a little technical problem there. Going to do number 27. So we have a plane that passes through a point, which, good, we have a point given to us. And it contains the line. So this is a point that's on the plane. And it contains, the plane that we're looking for contains the line x equals 4 minus 2t, y equals 3 plus 5t, and z equals 7 plus 4t. All right, let me try and show you what's happening here. We have a plane that we're trying to figure out what it is, right? What the equation is. We're given a point that lives on the plane. So there's a point, this point lives on this plane. We also are told that this line, right, this plane contains this line. So that whole line lives on this flat sheet of paper also. So what's the equation of this? Well, to find the equation of the plane, we need two things, right? We need a point and we need a normal vector. The point we have, so we just need the normal vector, right? Well, the normal vector is any vector that's going to be popping out of this plane perpendicular to the plane. So what I'm going to do is going to be pretty clever. I'm going to try and figure out any point on this line. So I'm going to pick some point that lives on the line. I'm going to find it. That's going to be easy to do. I'm just going to plug in t as 0, and that should spit out a point. And then I'm going to create a vector that goes from here to here. Then I'm going to look at this line and I'm going to look at its direction vector. So its direction vector must be parallel to this line, so its direction vector be something like that. And notice that if I take these two vectors and I cross them, right, if I do the cross product, I should get a vector that is perpendicular to both. And since both these vectors lie on this plane, the cross product should be a normal vector, should stick out of my plane. So I've got to figure out what these two are and then cross them. So I'm going to try and draw that on the board. It won't look as good on the board because my board is already flat here. So I have a point. That's the point 6, 0, negative 2. I've got some line, and now I'm going to find another point on that line. So if I come over here to the line, I let t be 0, boom, boom, boom. I'm going to get what? 437. 0.437. Now, I need a direction vector. Sorry, that's supposed to be like on that line. Direction vector of this line. And that I could use the v, the direction vector for this line, which comes from these numbers right here. So that v is equal to the vector negative 2, 5, and 4. All right? And now I will create this vector which goes from here to here. And that I can do just by taking the vector that goes from this point to this point. I go 6, take away 4. So this is the vector, let me call this vector u. This is the vector, 6 minus 4 is 2. 0, take away 3 is negative 3. Negative 2, take away 7 is negative 9. So if I take u and I cross it with v, it's going to pop me out a perpendicular vector to both. That vector is either going to stick out like this or it's going to stick in. So it's kind of like when I cross these, depending on the order I do it, it's either going to be sticking out of the plane or it's going to be perpendicular but sticking out the bottom like this. Doesn't matter, they're parallel. And normal vectors, doesn't matter which side it's pointing out. So the normal vector for my plane, right, is going to be the cross product of u and v. So the normal vector that I'm looking for is going to be, I'll do u cross v, which is u is 2, negative 3, negative 9, and cross that with v, which was the direction vector of the line, negative 2, 5, 4. So when we cross these, what we do is, we line them up vertically. and then we do our, covering things up. So this should be equal to, I'm going to do this, change it like this. So I'm doing that, crossing with that. So if I want to find the I component, right? The I component, I cover up I. And then I go, negative 3 times 4 is negative 12. Okay, so negative 12, and then I take away negative 45. So negative 12, and I take away negative 45. So that's same as negative 12 plus 45, which is going to be 33. Now I cover up the middle one. I get 2 times 4 is 8, and then I take away positive 18, right? So 8, take away positive 18 is going to be negative 10. But then I switch it to positive. And then I cover this up, I get 10, and then I take away positive 6, so that's going to be 4. Just check that, make sure I got that before I go any further. Yes, okay, so that's it. That's my normal vector. And that's all I need. I have a point in a normal vector. I just go into the formula now. Here's my A, my B, my C. And there's my x naught, y naught, z naught. So I'm going to have something like this. 33 x minus 6 plus 10 y minus 0. So that's just 10y. I'll write y minus 0. And then plus 4. And then z minus negative 2 is plus 2 equals 0. So 33x minus, what's that, 90 plus 18 is 108. And then plus 10y plus 4z plus 8 equals 0. So 33x plus 10y plus 4z equals, and then let's see this and this together, that's negative 100, and so bring it to the other side, 100. Looking like this is it. This is 27. 190, what the hell? What did I mess up? 4, 10. What did I screw up? Oh. See, this is what I'm talking about. Like when it comes to arithmetic, my brain just does not want to work. I don't know. I think as I've gotten older, I don't know, my brain's just become more lazy. 33 times 6. So it's 180 plus 18. I said, I don't even know what I said, 100 plus 18? 90 plus 18? I don't even know. This should be 180 plus 8, so 198. That should be 198. I put 108. I hope you're just sitting there laughing at me right now. Okay, and then this side right here, this will become 190. I'm glad I have the answers there to double check because it's ridiculous arithmetic like that. Okay. Oh, I should mention that if you happen to have crossed these vectors the other way, v cross u, you're going to get the same result except all these will be negative. And the effect that that has over here is that everything changes. Negative, 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 and then this is negative also. So just FYI. Where are we? 28. I need to go back to elementary school and do my arithmetic again. 28. I may have mentioned this before, but it's a misconception that math people are really good at like calculations. Like I've never been a human calculator where I'm just like, 197 times 243 is blah, blah, blah. It's just, that doesn't mean you're a math person. Okay, what we're doing here, this means you're a math person. That's my opinion. the plane that passes through the point, so I'm still trying to find the equation of a plane that passes through this point, so I've given a point, great, and contains the line. So it contains the line, this is just like the previous problem. With the symmetric equations, x equals 2y equals 3z. So this is exactly like the previous problem. We have a point that lives on our plane, we have a line, so we're going to create this new vector and we're going to cross them, and just like the previous one. The only difficulty is maybe this right here, because we're given symmetric equations instead of parametric. So let me just remind you what this means. This means that x is t, that 2y is t, and that 3z is t. All right, so from here we can solve these for x, y, and z. This is x is t, this is y is 1/2 t, and this one is z is 1/3 t. So there are your parametric equations from your symmetric equations. And so when I have my point here, 1, -1, 1, and I have this line, I'm going to get my direction vector off of this, which we call v. I'm going to get a vector connecting these two, which we called u in the previous problem. I just need to find that point. And the point is any point that lives on this line, so just plug in a value for t. How about 0, right? 0, that's just 0, 0, 0. Hey, so the origin lives on this right here. And the direction vector v, that's equal to, what's the direction vector of this line? It's the numbers in front of the t, so 1, 1/2, and 1/3. Now I'm not going to want to cross that because that's got fractions. So instead of using this one, since it doesn't matter, it can be any vector on this line, why don't I just multiply this through by, let's say, a common denominator? So how about 6? This is the vector 6, 3, 2. Okay, so that is a direction vector, points in the same direction as this one. I may as well use that. It has nicer numbers. And I've gone so far on this problem, I may as well finish it, I guess. What is u going to be? U is going to be the vector from here to here. Well, that's all these minus 0, so that's just 1, -1, 1. All right. So I'm going to say that the normal I'm going to use for my plane here is going to be the v, which is this vector, 6, 3, 2. And I'm going to cross it with this vector, so I'm going to do it vertically. Cross it with 1, -1, 1. And that will be equal to, let me take my time here. I'm going to cover this up. This is 3. Take away -2, that's the same as 3 plus 2, that's 5. And then cover up the middle, right? 6 take away 2 is 4, but then subtract it, so -4. And then cover up this one. -6 take away 3 is -9. And so what I should have here is hey, how's it going? Come on in. I'm recording right now, but I'm almost done with this problem, so give me just a second. So this is A, B, C. This is x naught, y naught, z naught. So we have 5, and then x minus 1, then minus 4, and then y minus, or plus 1, and then minus 9, and then z minus 1 equals 0. And this gives me 5x minus 5 minus 4y minus 4 minus 9z plus 9 equals 5x minus 4y minus 9z. Let's see if I can get this constant. -9 plus 9 is 0. So nothing. And this was number 28, so yay, I did my arithmetic right. Okay, so that's number 28. Time out. Give me a second. 29. So we're still finding the equation of plane that passes through a point. So hey, man, they just keep on giving us these points, making our lives so nice. And contains the line of intersection. Contains the line of intersection of the planes x plus y minus z equals 2 and 2x minus y plus 3z equals 1. Okay. Well, let's take a look at this one. We're trying to find the equation of some plane, right? It has a point on it, so we've seen something like this before. And it contains a line. There it is. The difference between this problem and the previous problem is that in the previous problems, we actually were given the equation of this line. We were given the parametric equation, and then in the last problem, the symmetric equation. So it's pretty easy for us to figure out the information we needed about this line because we actually had it. It was given. But this black line right here is actually not given to us here. We're told that this black line comes from the intersection of these two planes. So forget this plane for a second. We're not messing with this. Just focus your attention on this line. Where does that line come from? That line is the intersection of these two planes. So we have two planes sitting out here, and they intersect. It's probably hard to see on the camera, but they intersect. And where they intersect, they form a line. That's the line that we have here. So what we're going to have to do is we're actually going to have to find the equation of that line first from this. Then we can do the rest of the problem the way we did the previous two. So how do we find the intersection, the line of intersection of two planes? Well, what do we need to find the line? So to figure out what this line is, right, we need two things. We need a point on the line, and we need a direction vector, right? So can we find a point on the line? Well, a point that lives on this line lives on this plane and on this plane because the line is the intersection of the two. So if I can just figure out an x, a y, and a z that make both of these true at the same time, I will have a point. We've done something like this before. What I'm going to do is I'm going to take these two equations, I'm going to let z be 0, and I'm going to write out what I would have. X plus y equals 2, and 2x minus y would equal 1. And then I'm going to solve this system of equations for x and y. And this is going to be nice because if we just add down right now, we get 3x equals 3. Look at that. 3x is 3. Perfect. X is 1. Once I know what x is, I can come back up into this equation. It's 1 plus y equals 2. So that means y is 1. So if x is 1, y is 1, and z is 0, both of these equations should be true. So I have a point that lives on the line. The point is 1, 1, 0. That point lives on this line. Since that point lives on this line, I can use it as R naught. And R naught will be 1, 1, 0. All right, now I need the direction of the line. So going back to that picture, or actually I didn't draw a picture. We had these two planes hitting each other. So we have some line down here. Let me actually draw a line. Okay, this is the line that we're interested in, right? To find the direction of that line, what we'll do is we'll take the normal, and I've done this in class, so this is not new. Take the normal of this plane, the normal of this plane, I cross product them, and it will give me the direction of this line. So I need to take the normal of this plane and normal of this plane, cross them together. So V here, my vector V, my direction of my line of intersection is going to be the normal of this plane, I'm going to call it normal 1, crossed with the normal of that plane, I'm going to call it normal 2. And that we can find their normals pretty easily. The normal of this plane is 1, 1, negative 1. It's just the coefficients of x, y, and z. I'm crossing that with the normal of this plane, which is 2, negative 1, 3. And now I go ahead and get that cross product. I'm going to run out of room there. I'll put it up here. V is equal to, all right, so good old cross product here. Cover up the I. Get 3, take away positive 1, that's 2. Okay, cover up the J, so we get 3, take away negative 2, so that's same as 3 plus 2, which is going to be 5, but then it's the J, so we subtract it, so negative 5. And then cover up this, we get negative 1, take away 2, that's negative 3. All right, we're in business. We have now the information that we need about the line of intersection. I can now say that this line of intersection is this line right here. So I'm going to put R naught plus TV together. So it'll be 1 plus 2t, 1 minus 5t, and then 0 minus 3t. That is the vector equation of that line. I hope that you understand what I've done there, right? The vector equation of a line is R naught, the vector R naught plus TV. So putting that together, we get that. And I am on camera, barely. All right, so what we can do is we can start this whole problem over. We can say, all right, find the equation of the plane that is, that goes through that point and contains this line. And now we just do what we did previously. We have a point, we have a line, we find a point on this line, we create a vector that goes from here to here. This is the point negative 1, 2, 1. We find the direction vector of this line, which we actually have it. It's the vector 2, negative 5, negative 3. We need a point on this line. We can get the point from right here. This is the point 1, 1, 0. And then we need this vector right here, so we go negative 1 minus 1 is negative 2. 2 take away 1 is 1. 1 take away 0 is 1. So we've got it all there. So the normal of my plane that I'm looking for, right, is going to be this cross with this. So it's 2, negative 2, 1, 1, crossed with this vector, 2, negative 5, negative 3, right? And then I'll need a point on the plane, which I already have, so I'm not even thinking about that. So when we cross these, my normal will be, okay, cover this up. So we've got negative 3, take away negative 5. That's the same as negative 3 plus 5, so that's 2. Cover up this one, we've got 6, take away 2, 4, but then change the sign, so negative 4. And then finally, cover this up, 10, take away 2 is 8. Hey, they're all divisible by 2. I think I'll use 1, negative 2, 4 instead. You could use that, but I'm just going to make it a little easier. So now finally, I'm ready to come up with the equation of the plane. A, B, C, x naught, y naught, z naught. So it'll be 1 times x plus 1 minus 2 times y minus 2 plus 4 times z minus 1 equals 0. And this gives me x plus 1 minus 2y plus 4 plus 4z minus 4 equals 0. X minus 2y plus 4z, 1, 5, oh, those are gone, so 1 is negative 1. Let's see, this is number 29. Check this real quick. X minus 2y plus 4z is negative 1. There we go. That's it. That's cool, man. I hope that made sense. 30. Find the equation. So we're still finding the equation of plane here. Find the equation of the plane that passes through the points. So it gives you 2 points. 0, -2, 5. Another point, -1, 3, 1. And is perpendicular to the plane lost my spot here. 2z equals 5x plus 4y. Just double check everything here. We've got 2 points and we've got a plane 2z equals 5x plus 4y. All right, so let me try and figure out what we got here. I'm trying to find the equation of this plane right here, okay? It contains 2 points. There they are. And then I can tell you that my plane is perpendicular to some other plane. So there's a plane sitting out here. The plane that I'm looking for must be perpendicular to this given plane. So that means they must hit at a right angle, like this. Okay. So what do I need to find the equation of a plane? I need a point. I need a normal vector. Do I have a point? Absolutely, I have 2 of them, so I'm not worried about that. I just need a normal vector. So I need a vector that's going to be sticking out of my plane, right? Here's my 2 points. The fact that this plane is perpendicular gives me something here. Let's take a look at this. Remember that this plane right here has a normal vector coming out of it. There, like this. And that is perpendicular to my plane. So if I were to imagine that normal vector without this plane being here, it's running perpendicular. The plane is perpendicular, the normal vector, sorry, is parallel. Do you all see that? I think I said that wrong. The plane is perpendicular, that was here. The normal vector of that plane is actually going to be parallel to my plane. So this vector lives on this plane. So I can, to try and find this vector coming out, right, I can use this vector that's on my plane as one vector. I can connect these 2 points together and create a vector which I'll call u, okay? And so remember, I've got the vector from the plane, the normal vector from the plane that's perpendicular coming down here. I can always draw this vector. If I take those 2 vectors and I cross them, I will create this vector. Okay, I hope that makes sense. All right. So, what is the normal vector of this plane? Now, I don't want to confuse it with the normal vector of the plane I'm looking for. So I'm going to call this n, how about n sub p? So everyone knows this is the normal of the perpendicular plane. All right, the p is for perpendicular. So what is the normal of this perpendicular plane? Well, let's get everything to one side, all right? We have to get everything to one side first. So 5x plus 4y minus 2z is 0. So the normal vector is 5, 4, negative 2. So you notice if you didn't move the 2z over, you wouldn't have got that it was negative. So there's the normal of the perpendicular plane. So here's the plane I'm looking for. I have the 2 points that were on that plane, and I just came up with the normal of the perpendicular plane. I'm slapping it down onto this, and I can slap it anywhere I want. Here it is. Here's the n sub p. But because it's a vector, I can slide it around. So I'm just going to move it instead of there. I'm just going to attach it to that point right there. So there's your np. And then I'm now going to come up with a new vector that's going to connect these points together, which I'm going to call u. And then I know that if I cross these 2 together, I will get the normal out of the plane I'm looking for. So how about we come up with u right now? U will be the vector connecting our 2 points together. So it doesn't matter which way I go. I think I'm going to go from this point to that point. So 0 take away -1 is 1. -2 take away 3 is -5. And 5 take away 1 is 4. So that's this vector. So I've got my two vectors on my plane. Cross them now, and that's the normal I'm looking for. So the normal that I'm looking for is going to be the cross product of u and the normal of that perpendicular plane, which for me is the cross product of 1, -5, 4. That's this. And then the normal of the perpendicular plane, which I erased, but it is 5, hold on, let me look at, it's 5, 4, -2. All right, let's figure out what that is. That is covering up the I. Let's see, 10, take away 16. Is that right? 10 take away 16, -6. And then cover up these. I've got -2 take away 20 is -22, but then change the sign. And then cover this up. I've got 4, and then take away -25 is 29. That looks weird. Number is 30. Let me just double check that. Yep, that's right. Okay. So I'm in business. So this is my ABC of the plane I'm looking for. This is, I'll use this one as my point. So I have -6, x minus 0, plus 22, y plus 2, and then plus 29, z minus 5 equals 0. And if you simplify this down, you get -6x plus 22y plus 29z equals, I'm going to cheat here, 101. 101. There it is. That's the equation of the plane. So cool. How am I doing on time here? Trying to get through 31 and 32. So on 31, let's see if I can maybe help you get this without me doing it. It gives you the point 151. This point lives on your plane. And then you're told that it must be perpendicular, okay? The plane you're looking for is perpendicular to both 2x plus y minus 2z equals 2, and is also perpendicular to x plus 3z equals 4. So this one's a little different than the last one. You have a plane that you're looking for, right? You have a point on that plane. And then all you're told is that this plane that you're looking for must be perpendicular to this plane and a different plane at the same time. Well, remember we did in the last problem. We had, when we said that our plane is perpendicular to some other plane, we said if we took the normal off of this plane and dropped it down onto our plane, it would live in our plane. It would be parallel to our plane. And the other plane, okay, the other one, same story. If we take its normal and drop it down onto our plane, it will live and be parallel to our plane. So if we take the two normals of these two planes and drop them down to our plane, they both live in there. If I cross those two, I get a normal coming out of my plane. And then I have a point. So I have a point, and then the normal vector is just taking the cross product of the normals of these two. So without going through all the work, let's just say this. The point that I have is the point 151. The normal for the plane I'm looking for is the normal of this one, normal of plane 1, crossed with the normal of this one, the normal of plane 2. And what is the normal of plane 1? Move everything to one side. 2, 1, negative 2. And what is the normal of this plane? So notice there's no y in there. That means you have 1 in front of x, 0 in front of y, 3 in front of z. Cross these two together, you get your normal, you've got your point, plug everything in, you're done. How about 32? Find the equation of the plane that passes through the line of intersection of planes, blah, 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 and is perpendicular. I'm going to let you do that. Yeah, I'm going to let you do that. How about 33? Okay, let's do 33. I'm getting hungry. 33. Find the point at which the line x equals 3 minus t, y equals 2 plus t, and z equals 5t intersects the plane x minus y plus 2z equals 9. All right. So this is the first problem since number 21 all the way to 32. You're trying to find the equation of plane, equation of plane, equation of plane. This one's totally different. This one is saying find the point where this line right here intersects this plane. So you have a plane, you have a line. Where do they hit each other? Where's that point? All right, well, in order to live on this plane, this equation must be true. In order to live on this line, these three equations must be true. So we know what the value of x must be. It must be 3 minus t. So if I come over here and I replace x with 3 minus t, and then go minus, and then I replace the y with this, 2 plus t, and then plus 2 times z, but z is 5t, that must equal 9. And what that'll allow me to do is solve for the variable t. 3 minus t minus 2 minus t plus plus 10t equals 9. So how many t's do I have here? 8 t's. And then 3 minus 2 is 1, and then take it to the other side, you get 8. Ooh, that's nice. T is 1. Is that the answer? No, because we want to know the point where they hit each other. So where is this point? It's the point that you get when you let t equals 1. So I come back over here and I just let t be 1. If I let t be 1, I get x is 2. Let t be 1 here, I get 3. Let t be 1 here, I get 5. So you can verify for yourself. I mean, we know this point lives on this line, right? Because you just plug in t is 1 and you get this point. So that definitely lives on this line. Does it live on that plane? It should. Let's just check it. Plug in 2 here, so 2, take away y, 3, plus 2 times 5. Is that 9? Yes. So that point lives on this plane and it lives on that line, therefore it is on their intersection. 35. Determine whether the planes are parallel, perpendicular, or neither. If neither, find the angle between them. All right, so I'm going to do number 35. You're given two planes. x plus y plus z equals 1. Given another plane, x minus y plus z equals 1. And what I'm trying to figure out is whether or not these planes are parallel, perpendicular, or neither. So if we have two planes sitting out in space, they're either what, parallel to each other, they could be perpendicular to each other, or neither, right? They could just be off like that or something. So I'm trying to determine that. Well, let's talk about parallel. If they're parallel to each other, like, like this, then the normal vectors for both of these are parallel. So let's talk about the normal for this first plane. It's the vector 1, 1, 1. What's the normal for this plane? It's 1, negative 1, 1. Are these vectors parallel? Are they scalar multiples of one another? Is it possible to turn n1 into n2 by multiplying by a number? It's not possible. You can check it yourself. Okay, so plane 1 is not parallel to plane 2, all right? Because the normal vectors are not parallel. Remember, these don't have to be exactly the same. They just have to be off by a scalar, which they're not. Okay, so they're not parallel. How would you check to see if they're perpendicular? Well, if two planes are perpendicular, I hope it's obvious to you that their normals would also be perpendicular. So the question would be, are these normals perpendicular? So how do you check to see if two vectors are perpendicular? You dot product them, right? And you hope for 0. What's the dot product of these two vectors? Remember, dot product is a number. So you do first components multiplied, 1 times 1 is 1, plus second components multiplied, 1 times negative 1 is negative 1, and then 1 times 1 again is 1, and you get 1. And that is not 0, therefore they are not perpendicular. So plane 1 is not perpendicular to plane 2. So since they're not, it wants us to find the angle between them. So that means we've got these two planes that are hitting each other, but there's an angle between them, and we want to know what that angle is. Well, in order to find that angle, or the angle between the two planes is equivalent to the angle between the two normal vectors of the planes. So what I need to do is find the angle between those two vectors. So how do you find the angle between those two vectors? We go back to a formula we had. Theta equals arc cosine of, in this case, n1 vector dotted with n2 vector over magnitude of n1 times magnitude of n2. Whatever that is the angle between them. So this is going to be cosine inverse of the dot product of the two, which we did just a second ago, is 1. The length of n1, so this is where you do the square root of each of these squared, you'll get root 3. And then the length of this one squared is also root 3. So you get arc cosine of 1/3, which I don't have my calculator with me, is about 70.5 degrees. So about 70.5 degrees. That is the angle between the two planes. Now, number 37, which is the last problem out of the homework assignment, I'm going to let you do yourself, but I'll tell you what the answer is. Those planes in number 37 are parallel. So that's it. That's all I'm doing for this section.